Assalamu alaikum students. Welcome to our online chemistry class of Cosmic School. Hope all of you are fine by the grace of Almighty Allah. Today I will discuss about a very important hydrocarbon derivatives, which is carboxylic acid or fatty acid. The organic acid which have a carboxylic group is called carboxylic acid or fatty acid. That means which is carboxylic group, this monovalency COOH group is known as carboxylic group. It's a functional group. That means the organic compound which contains this group is called carboxylic acid or fatty acid. Carboxylic acid, the general formula of carboxylic acid is CnH2n plus R COOH. This is the general formula of R and this is the functional group of carboxylic acid. So we can symbolize in short carboxylic acid like that. R, which is alkyl group, any alkyl radical, and COOH carboxylic group. And since we called it acid, that's why it has the capacity to donate H plus ion, but it's a very weak acid. All organic acids are very weak acid. What is weak acid? Do you remember, students? We have already learned about that in chapter 9. The weak acid means the acid which can very slightly dissociated in aqueous solution, that means in water, and produce a slight amount of H plus ion, that means proton. We know that H plus is responsible for the property of acidity. That means the reaction will be CH3COH, it's ethanoic acid, aqueous. Of course, the decomposition happens in presence of water. That's why we write aqueous. We have to mention this aqueous condition, and then this acid decomposed into CH3COO minus aqueous ion, its ion, and plus H plus. This H plus is responsible for showing the properties of acid, but it's a very weak acid. That means that's why we use this sign. This means after some times after decomposing some molecule of acetic acid, they reach the equilibrium, and that's why the decomposition will be stopped. And we can tell for acetic acid, out of 1000 molecules of acetic acid, only 4 molecules will be decomposed in water at 25 degrees centigrade temperature, that means room temperature. That means very slightly decomposed in water, and rest 996 molecules remain intact in water. That's why it's a weak acid. And how can we name this carboxylic acid? At first, the carboxylic acid named by removing E from their corresponding alkane's name. That means if we take as example propane, 3 carbon containing alkane. Then we have to first remove this E and then add OIC, OIC. Then propanoic acid. This is the rule, this is the system to name any carboxylic acid. At first, we have to remove E from their corresponding alkane's name. Then we have to add OIC with this name. And then we get and add, obviously add with that acid. That means the final name is propanoic acid. Or from butane we get butanoic acid. From hexane we get hexanoic acid. I think it is clear. Now, since carboxylic acid, this group, carboxylic acid is an acid, that's why it can easily turn the blue litmus into red litmus. How come? This acid produce and proton, and this proton can turn the blue litmus paper into red litmus. And for identify any acid, at first we use this blue litmus, and this experiment is proof that this solution is a acid solution or acidic solution. Okay, then like other acid, it show the main characteristic reaction of any acid or any base also. Acid can react with base and produce salt and water. Students, all of you are known about this reaction. It's a neutralization reaction. In neutralization reaction, acid reacts with base or alkali and produce salt and water. And acetic acid or any organic acid also show this characteristic reaction. Acetic acid, and we have to take a base or alkali aqueous solution of sodium hydroxide. We take a sodium hydroxide alkali, and then it reacts and produce sodium acetate and obviously water. This is the salt and this is water. It's a neutralization reaction, and the name of this salt is sodium ethanoate. Or we can also call it sodium acetate, because ethanoic acid is known as acetic acid also. Sodium acetate or sodium ethanoate, and this is a salt, and a salt have two parts. All of us know about that. One is positive part and another is negative part. Positive part comes from the base, and that means cation part comes from the base, and anionic part, that means negative part, comes from the always acid. And here from acid come acetate ion, and from alkali come sodium ion and sodium acetate, and this remaining portion OH and this H produce H2O, water. And a very important question, and maybe come in your SSC exam in CQ also. this is that prove that or show that CH3COOH is a acid or is a weak acid. Prove it. Then we have to answer this with these two reactions. First one is decomposition of acetic acid, and then the neutralization reaction with any alkali or base, and then you have to tell this is a acid. Now we have to read the preparation of carboxylic acid, and we consider the first member of carboxylic acid group, which is acetic acid. Okay, then how we can produce acetic acid? Acetic acid can be prepared by oxidizing ethanol. Ethanol, that means it's ethanoic acid. Its corresponding aldehyde is ethanol aldehyde. We have learned about that in our last lecture. Aldehyde group, that means aldehyde group CHO. This is the aldehyde group. This is the aldehyde group, and 2 carbon are present there. That's why it's ethanol. This ethanol, if we oxidize this ethanol, we get the product which is corresponding carboxylic acid. And for oxidizing any organic compound, we use a popular oxidizing agent is potassium dichromate and dilute sulfuric acid. The mixture of potassium dichromate and dilute or light sulfuric acid. We have already used this oxidizing agent in our last class. Then oxidizing agent, potassium dichromate and dilute sulfuric acid. At first, these two reagents reacts with each other and produce nascent oxygen. Nascent oxygen, very active oxygen, and this nascent oxygen is responsible for the oxidation of ethanol. This aldehyde, this oxidizes this group, and in that case, here oxidization occurs by adding oxygen in this functional group. Oxidization occurs by adding this oxygen into this group. Then the product will be CH3COOH. This group turn into this group. Then we get the acetic acid, corresponding acid, and no byproduct. This is the final product. Okay, that means, I repeat, ethanol in presence of a strong oxidizing agent. This is a strong oxidizing agent. Potassium dichromate in presence of dilute sulfuric acid reacts and oxidized and produced ethanoic acid or acetic acid. This is very important reaction. This reaction used for many purposes in the study of this chapter 11 chemistry. Now another reaction for preparing ethanoic acid, which is, at first we have to take ethanol. from alcohol. Students, look and notice carefully. Here we take ethanol. This one was ethanol. It is ethanol. It's a alcohol. OH group present. And it is also oxidized by in presence of oxygen, in presence of direct oxygen, but we have to give here a bacteria in presence of acetobacter. This reaction happens in presence of acetobacter. Then we get the alcohol oxidized and produce corresponding acid. Student, notice that here 2 carbon present, also 2 carbon present in the produced product, the produced acid. No reduction or improvement in the number of carbon. Okay, this is the 2 method you have to learn for preparing acetic acid or ethanoic acid. This was the all about carboxylic acid for now. Now we have to discuss about some more reactions. We have to learn about how these 3, we have learned about 3 hydrocarbon derivatives, and now we have to know how these 3 hydrocarbon derivatives can be prepared from hydrocarbons. That means alkane, from alkene, from alkene, from alkyne. Using alkene and alkyne, we have to prepare their derivatives alcohol, aldehyde and carboxylic acid. And let's see. At first, start with alkane. Start with propane. Propane has 3 carbon in its molecule, 2 and CH3. This is the propane. Students, whatever I write on this board, I hope you also write in your copy, because it will be helpful for you. And then this conversion reactions involves sometimes a series of reactions. Okay, students, are very important for your exam. At first, alkane, that means saturated hydrocarbons, reacts with converts into their corresponding alkyl halide or haloalkane. Be careful, listen carefully. At first, we have to convert the alkane into their corresponding alkyl halide or haloalkane. That means from propane, we have to get propyl halide. That means propyl chloride. It may be propyl bromide. It can be propyl iodide. Okay. Then, and for that, we know that alkane show very limited amount of reactions, and very special condition is needed for that, because they are inactive into any chemical reaction. At first, propane reacts with halogen. Okay, halogen. We can take chlorine. Halogen means halogen. It can be bromine also, but I take chlorine here, and then a substitution reaction will be occurred. Okay, a substitution takes place. Okay, from here the terminal carbon, from this terminal carbon, one hydrogen atom replaced by one chlorine atom, and we get corresponding alkyl halide. That means CH3, CH2, CH2. We have to remove one hydrogen by one chlorine. Chlorine has valency 1, hydrogen also 1. One chlorine can remove one hydrogen. That means Cl. And this another chlorine goes with this hydrogen and produce HCl. Okay, is it clear to you, students? Then we get the alkyl halide. Look, this is the propyl group, alkyl group, and this is halide group, alkyl halide. That means the name of this compound is propyl chloride. Now this propyl chloride, our target is derivatives, hydrocarbon derivatives. This is also one kind of hydrocarbon derivatives, but our target is alcohol, aldehyde and acid, carboxylic acid. So next one I have to remove, but you write sequentially one by one. Okay. Now our reactant is propyl chloride, and we have to get ethanol. That's why in this propyl chloride, when we add aqueous sodium hydroxide, one information was missing for our last reaction. This reaction must have to do in presence of sunlight or UV light. In presence of sunlight, only in presence of sunlight, alkane, the saturated hydrocarbon, inactive hydrocarbon, reacts with chlorine or bromine and produce corresponding alkyl halide. Okay. Now proceed on. This is halide. When we add aqueous sodium hydroxide, aqueous sodium hydroxide or potassium hydroxide, then we get corresponding alcohol. Okay, let's see sodium hydroxide. Of course, this sodium hydroxide is prepared in aqueous solution, in water. We need aqueous sodium hydroxide or potassium hydroxide. Then we get alcohol. Otherwise, we know if we take alcoholic, we have learned about that. If we take alcoholic potassium hydroxide or sodium hydroxide, then the product will be alkene, corresponding alkene. Okay, for that this is aqueous, AQ, mention AQ, and then we get corresponding alcohol. That means carbon number will be same. Propyl alcohol. We get propyl alcohol, OH. This is also a displacement reaction. So chloride, the negative part of this propyl chloride, displaced by or substituted by OH group. Okay, then here OH is produced and along with sodium chloride produced. Okay, we get the alcohol, one hydrocarbon derivative. Our one target is fill up. Okay, fill up. And now we have to get the corresponding aldehyde, and we learn about that in our last class. Now we have to apply to this oxide. Simply we have to oxidize this OH group. This group. We have to oxidize this group, and Do you remember? This oxidization happens by the removal of hydrogen, but the oxidizing agent are same. Potassium dichromate plus dilute sulfuric acid. Okay, then we get CHO. That means 2 hydrogen is removed by this nascent oxygen which is produced by reaction of potassium dichromate and dilute sulfuric acid. This nascent oxygen takes 2 hydrogen and produce water molecule, and this alcohol turns into aldehyde. And the name of this, can you tell me the name of this product is what? Of course, it is ethanol. Ethanol, aldehyde. This was ethanol. This is ethanol. Now, another target is filled up. Now, our next target is corresponding acid, carboxylic acid. I have to erase this because my board is too short, too small. Okay. Now our reactant is, for this reaction our reactant is the product of our last reaction. Okay, the product of now for this reaction is reactant. We have to apply the same oxidizing agent. We have to apply the same oxidizing agent. Okay, then further oxidation occurs. Potassium dichromate, dilute sulfuric acid is produced nascent oxygen, and this add with this aldehyde group. Here oxidation occurs by addition of oxygen, and our final product is carbon number same, just aldehyde group converts into carboxylic group by addition of one oxygen, active nascent oxygen, and no other product. Okay, no byproduct, only one product. For aldehyde, water was produced, but for in this case no byproduct is present. Okay, only acetic acid or ethanoic acid, and the name of this, propanoic acid. Oh, I was wrong for the last reaction. This is not ethanol, this is propanol. 3 carbons are present here. Okay, propanoic acid. Then students, is it clear to you how we can produce ethanoic acid from propanoic acid from propane? First, it's a 4-step reaction. It was a 4-step reaction. Can you remember that? At first, we take propane, then converts it propyl chloride. First reaction. Okay, number 1 reaction. Then this chloride converts into corresponding alcohol. That means propanol, propyl alcohol, which is done by using aqueous sodium hydroxide or potassium hydroxide. After that, we use oxidizing agent. The third reaction was conversion of alcohol into aldehyde. In that case, we use potassium dichromate in presence of dilute sulfuric acid, which is a strong oxidizing agent. Then we get aldehyde, corresponding aldehyde, which was propanol. After that, further oxidation occurs by same oxidizing agent, using same oxidizing agent, and we get propanoic acid. You have to practice to adapt this series of reactions. Okay, student, that's all for today. Read properly and regularly. Be happy, be safe. Assalamu alaikum.